So in this video, I'm going to introduce you to resistance and resistors. So a resistor has a symbol like this. So that's the symbol of a resistance. And usually each resistor has a quantity associated with it, which is called a resistance. And this resistance is usually measured in units called ohms, which in short form is written as the capital omega of the Greek alphabet. Okay, and the basic idea of a resistance is that if you apply a voltage, let's say V, across it, a current would flow through it. Okay, and the voltage and the current are related in this manner. V will be equal to I times R. Or, in other words, you could say the ratio of the voltage and the current is a constant, which is called the resistance of that resistor. Now, as we are measuring voltage, the voltage is usually measured uh, in volts, and the current is measured in amperes. And when that is the case, when the voltage is in volts and the current is in amperes, the resistance R will be in units called ohms. Okay, so now that we have defined a resistance, let's just take a voltage source. So this is called a voltage source. This is an electronic component that uh, puts voltage across any component. Okay, so you take a voltage source and you connect it to a resistor. Let's say the resistance of this resistor is R, and the voltage that this source is applying is a voltage called V. Okay, and now let's just think about the behavior of the circuit. Now, if you look at the top part of this voltage source and the bottom part of this voltage source, what we are basically saying is that this voltage source is maintaining, let's call these points A and B. So the voltage source is maintaining a voltage difference between point A and B. And A is the more positive point and B is the more negative point. Okay. The connection here that has been shown basically is showing an equipotential connection, which means that the potential at this point, let's call it A prime, is the same as A. In the same way, the potential at B is the same as at B prime, which is this point. Okay, so what is the voltage across A prime, B prime? It is the same as the voltage across A and B, and the voltage across this resistor, that is across points A prime and B prime, is also V. Which is the more positive point in both these? The more positive point is A prime because it's connected to A, and the more negative point is B prime. So the voltage here across this resistance is also V. How about the current? How does the current flow? So in general, you can assume that the current flows out of the positive terminal of the voltage source. So the current flows like this. It goes through this wire into the resistance. It comes out, flows through this wire back into the voltage source. Now, one of the things that you should remember in all electronic circuits is that current flows in closed loops. What that means is that if a current is going out of this voltage source, the same current has to return back to it. And the reason that is true is because we cannot have any accumulation of charge in this circuit. Okay, neither can we create or destroy charge. So the current that is going here needs to return back. Okay, so let us call this current that is flowing in this circuit as I. Now, is there a relationship between V and I? And of course there is, because we know that there is a resistor here, and we know that the voltage that is applied across this resistance is V, and we know that the current that is flowing through that resistance is I. So V over I has to be R, because that's the property of a resistance. And therefore we can just rearrange this equation and say I will be equal to V over R. So in this circuit, the voltage is set by the voltage source, and the current is decided then by this resistor that is connected across the voltage source.